Sama. Hello, everybody. We are starting our live stream in 5 minutes. All right. So please get ready. Today we are going through a very interesting topic, which is on counting 2D and 3D figures. Okay, this is a commonly tested topic. So do make sure to stay tight. Okay. And as you can see on the screen here, we are opening our registration for the first round of P2 mock tests for both SMKC and SASMO. So SMKC's mock test will be on 20th February, a Thursday. SASMO 25th on a Tuesday. Okay, and the time is 6 to 7:30 p.m. Now both tests are done online on your Think Academy app. Okay, if you are an existing student, okay, you can participate in these mock tests for free. Okay, so yeah, if you're a new student, it's also very worth it. Okay, it's just less than $5. Okay, very worth it in my opinion. So with that, yeah, if you are interested, feel free to scan the QR code on the left to register to our mock tests. Okay, slots are limited, and yeah, just feel free to scan and participate in whichever competition that you are interested in. All right, so we have 3 more minutes left before we start our weekly drill. Okay, so yeah, just hang tight. Maybe prepare your stationery and the all-in-one guide. Okay, however, most of the questions here today might not be found in the all-in-one guide, right? But the exercises will be taken from it. So yeah, just you know pay attention to today because this topic, counting 2D figures, is very commonly tested in SASMO. All right, so once again, for those of you who have just joined, mind, okay, we are opening our first round of registration for our P2 SASMO and SMKC mock tests in the latter half of February. So for SMKC, it will be on the 20th February, okay, a Thursday, and SASMO, it will be on a 25th February, which is a Tuesday. Okay, both timings are 6 to 7:30 p.m. Okay, 90 minutes for the test, and it will be conducted online via our Think Academy app. So if you are interested, okay, feel free to scan the QR code on the left to register for the mock tests. Okay, our slots are limited. If you are an existing student in Think Academy, don't worry, okay, you can participate for free. For those who are new students, the price is $4.90, okay, less than $5. I think it's very worth it. Okay, so take a look at the QR code on the left, okay, feel free to just scan it, okay, to register for whichever mock tests that you would like to participate, okay? So with that, and give you a few more moments, okay, to scan the QR code if you have yet to, okay, and yeah, SNKC 20 February, SASMO 25th of February. Okay, with that, we are going to talk about counting figures today, okay, both 2D and 3D. This topic, okay, is very commonly seen in especially the recent years of SASMO. You see counting cubes, counting triangles, right? Moving on to the more recent years, counting triangles, counting cubes, counting squares. It always comes out. Okay, so it's very important to grasp the basic skills, okay, to do these calculations or counting, okay? So, and also students can get easily careless in counting problems. So today I'll show you the foolproof way, okay, to count different types of shapes. Okay, are you ready? Okay, let's go. And we will start with counting cubes, okay? So I believe that most of y'all who have learned a bit of Math Olympiad should know that this is a common question in competitions for lower primary. So we have two methods to count cubes. Okay, the first one I'm going to count by columns, which is what I call the bald guy method. So you just imagine each cube, or rather each column of cubes, okay, is like a tower. It's like a bald guy. A bald guy has no hair. So we are going to start from the shortest column or the shortest tower. Usually, find the columns or the towers with only one cube. Okay, can you find out where is it? Okay, on this figure on the right, we have one column, two columns, and three columns with only one cube. So what we are going to do is, after we found the columns with one cube, okay, we label the numbers on top of these tower. So think about the roof of the tower, right? The part with no hair. So we just label one on top of these columns, okay? But then there still are other columns with, okay, more cubes. So let's work upwards to taller towers. Can you find a slightly taller tower, okay, among these columns? That's right, there's another column here, and this time I have one more cube on the top. Do note, although I only see one cube on the top, there's actually one secret hidden cube below, okay, to ensure that it supports the cube on the top. So then, this one, we have two cubes on the column, okay, from top to bottom, one shown, one hidden, so we label a 2 on top, okay? And then, furthermore, there are even taller columns. As you can see, here we have even taller towers. One more cube. So that means there will be 1, 2, 3, right? 3 cubes in this case. One step further, 3 cubes in the tower, label a 3 on top. This one, same, label a 3 on top. Okay, make sure all the top parts, all the heads have been labeled, okay, with a certain number, as you can see on the top. Okay, and finally, to find out how many cubes there are, we just add up all the numbers to find the total. Okay, so we have 3 plus 3 plus 2 plus 1 plus 1 plus 1, which is equal to 11 cubes. Okay, with that, we can easily find out how many cubes there are. Now, this method is relatively straightforward. Okay, you just need to think of the cubes by their columns. Okay. And then there's the second way, which is what I call the lazy guy method. Here we are going to consider by rows instead, okay? And I'm going to start from the top row. So looking at the top row, right? How many cubes do you see on the top row? Okay, in this question, there's only one cube on the top row, so we know there is one cube over here. Okay, now let's take a look at the next row, the row at the bottom, okay, the second top row. So for each of the rows, there are actually two types of cubes, okay? The first one is what I call lazy cubes. Why are they lazy? Because I can just see them hanging around. He doesn't need to support anyone else, okay? So over here, this second layer, okay, the blinking one here, do you think there are only three cubes? Well, even though you can see one, two, three cubes, it doesn't mean that the layer has three cubes, okay? There's only three lazy cubes. Lazy cubes are my cubes that are outside that you can see. However, think about why can the cube on top over here stand up so tall? There must be someone supporting it from below. So if we want to see a cube supporting it from below, this cube that is supporting it from below, we call it a working cube. Okay, it is supporting someone on top. How do we know how many working cubes are there? We just see how many cubes are there on the layer on top of it. On top of it, there is one cube, so we have one working cube. Okay, and then for the cubes that are lazy, we have one, two, three lazy cubes. So if we add up the working cubes and the lazy cubes, okay, we will have four cubes in the second layer. Four cubes in the second layer. Okay, so lazy cubes plus working cubes. Now we move on to the bottommost layer again. In the bottommost layer, how many cubes can you see directly? You see 1, 2, 3, 4, 5. Okay, 5 cubes. These are my lazy cubes. However, do I only have lazy cubes? I don't, because on top of this layer, I have more cubes. I need some working cubes to support the layers on top. How many working cubes are there? I know that there are 5 lazy cubes, but on the top layer, okay, just before it, we have 4 cubes, right? So we need 4 cubes on top. That means there must be 4 cubes at the bottom to support these cubes on top. Okay, so there will be 5 lazy cubes, but 4 working cubes that support the other cubes on top. Okay, to get 9 cubes in total in that layer. So using lazy cubes plus working cubes for each layer or each row, we can find out how many cubes are there in each row and finally add up all the numbers to find the total. So first layer, 1 cube. Second layer, 4 cubes. Third layer, 9 cubes. Finally, 9 plus 4 plus 1 will be equal to 14. And with that, we found the number of cubes. Okay, I see that a lot of you have already given the answer, okay, in the chat box. Very good. Okay, so with that, whenever you see a very complicated, diagram formed by cubes, remember there are 2 ways to do this. The first way is to count by columns using the bald guy method. So over here, we start from the shortest towers, label 1, 1, 1, 1, 1 on top of it, and then we gradually move upwards, right? 2, 2, okay, and then move upwards again, and then reach the top so that we can find out in each column how many cubes there are. Okay, whereas the second way is to count by rows. Counting by rows is what we call the lazy guy method. We start from the top row. We find out the top row has how many cubes. So over here, we have 1, 2, 3, 4, 4 rows. So we start from the row on the top. The top row has 1, 2, 2 cubes. Right. Now starting from the next row, okay, we will look at 2 parts. Number 1, how many cubes can you see directly in that row? So that will be 1, 2, 3, 4. 4 cubes that you can see directly. These are my lazy cubes. I can straight away see it. It is not supporting anyone else. Okay, or rather cubes that have nothing on top of it. How many cubes have nothing on top of it? So it's 1, 2, 3, 4. Nothing on top of it. That is my lazy cubes. Okay, then we will add the working cubes, because don't forget, I have 2 cubes on the top. That means on the bottom layer, I will need 2 more cubes to support them on the top. So these are my working cubes. All right. So finally add them up, and then you can find this layer, how many cubes are there. Then we move on to the next layer. Okay, and so on and so forth. And the next layer, I have only 2 lazy cubes with nothing on top. So we have 2 lazy cubes. But Remember, I need 6 working cubes for the 6 cubes on the layer on top of it. So in total, I will have 8. Okay. And then finally, same here, I have 1, 2, 3, 4, 5, 6, 6 lazy cubes, okay, together with 8 working cubes. The working cubes, just take how many cubes are there on the top layer before it, okay? And then you will get 14, okay? Now remember, 14 is not your final answer, okay? You need to add up all the numbers in all the layers to find out the real total number of cubes. 14 is just bottommost row, how many cubes are there. So you add up to get 30. Okay, now here's a little task for you. Try to find out, okay, using the counting by columns method, does it really add up to 30? Okay, right, so we have 2 methods for counting cubes. Count by columns, okay, from bottom to top, or count by rows, top row all the way down. Okay, so with that, we have gone through how to count 3D cubes. Now let's talk about a more commonly seen counting problem, which is on counting 2D figures. The first method I'm going to share with you is the shooting method. So first, let's look at this question. How many line segments are there altogether in this figure? Okay, so what does line segments mean? Line segment refers to having a part of a line, a straight line that has 2 ending points, okay, with limited length. So you need to find a starting point and then ending point for the straight line. That forms a line segment. Okay, so with that, let's take a look at how to count the line segments. Can I just say, I know, 1, 2, 3, I'm done. Okay, can I just say there are 3 line segments here? Okay, now absolutely not, because I may not have to choose 2 neighboring ending points to form my line segment. Okay, if I choose my ending point A and B, okay, this entire thing is also a line segment. So how do I correctly count how many line segments are there? So we are going to use the shooting method. So think about each point as having a target on it, and then you are standing on the left, okay, and you want to shoot to the target. Let's say you are standing at A, okay, at point A. You are shooting towards the right. Which points can you shoot towards? You can shoot towards B, you can shoot towards C, you can shoot towards D, right? So that corresponds to, from A, I can draw a line segment to B, I can draw a line segment to C, or I can draw a line segment to D. So with that, we know that starting from A, I already have 3 line segments, okay, if I shoot to the right. Then let's move on to B. Okay, what if I stand at B instead? Now, can I shoot back to A? Can I say just now I A shoot to B? Now I B shoot to A. Please don't, because we are only shooting to the right to avoid repeats. A to B and B to A, this leads to the same line segment, and we want to remove repeats. So with that, starting from B, just shoot to the right. We can shoot to C, we can shoot to D. So we know there are 2 more line segments we can find. Okay, with that, continue. If you stand at C, where can you shoot to? I can shoot to D, right? So this is my shooting method. So with that, C, I can have 1 more line segment starting from C, and that is just C to D. Okay, and what if I stand at D? Right, if I stand to D, can I shoot more to the right? Cannot, because D is already at the far right. Okay, so with that, okay, we just need to, add them up. 3 plus 2 plus 1 is 6. So there are 6 line segments altogether. Okay, so this is what we call the shooting method. Okay, we number the line segments from 1. Okay, so we list out all the line segments 1, 2, 3. Then we just stand on the left and shoot to the right. Keep on shooting, 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 and add up the number of shoots. Okay, so over here, 3 plus 2 plus 1. Okay, and then you add them up. So with that, let's take a look at this question. Okay, we are looking at the shooting method. How many triangles are there in the following figure? Okay, so let's see. You know that this triangle has something that looks like a lot of line segments, right? If you look at what's happening below. Oh, look. Each time I see 2 endpoints on this line, okay, I pick a line segment. These 2 points will shoot up to the same vertex on the top. meaning it will form one triangle. So each time I pick two different endpoints, I shoot out, okay, it will form a triangle together with the line segment that I formed. So essentially what I need to do here is to find out how many line segments are there. So to find out how many line segments are there, I can just use my shooting method, right? I can just use my shooting method. So think about it. I have 1, 2, 3, 4, 5. 5 ending points, right? 5 points that I can mark my line segment at. How many line segments can I write the number on? I can just write 1, 2, 3, 4, right? 1, 2, 3, 4. 4 line segments. And then I can just use my shooting method. Now, if I use my shooting method, if I stand on A, I can shoot to how many different targets? I can shoot to B, shoot to C, shoot to D, shoot to E. So that will be 4, right? Now, do you notice a pattern now? What if I stand at A, that's 4. If I stand at B, how many line segments can I draw towards the right? That would be 1, 2, 3. So 3 line segments, right? And then if I stand at C, again, I shoot towards the right. How many different targets can I shoot at? I can shoot at 1, 2. 2 different targets, right? So 4 plus 3 plus 2. But finally, don't forget, I can still stand at D. If I stand at D, I can just shoot to E, forming another line segment. So that will give me 10 line segments. Okay, I can just stop at D because once I stand at E, E is already at the far right and I cannot shoot any further. So with that, I've gotten my answer. There are 10 triangles. So this shooting method works because all the line segments, if I choose two ending points, they shoot up to the same vertex on top, right? So the number of triangles is just equal to the number of vertices, the number of line segments at the bottom. Okay, so with that, we can take a look at another application of the shooting method on rectangles. Okay, so over here, how many rectangles are there? Now, do you see something familiar to you? Right, doesn't this also look like a shooting method question? Right, how many line segments are there? Every time I pick two different ending points, if I shoot them up, okay, they are able to form a rectangle. Okay, pick any two ending points, shoot up, I can form a rectangle. So if that's the case, I can just use my shooting method to solve this problem. Okay, so shooting method, we label the segments first. We have 1, 2, 3, 4, 5, 6. 6 line segments. Okay, and if I have 6 line segments, if I use the shooting method, actually there is a pattern, right? 6 line segments. If I stand on the far left and I shoot to the right, I can shoot to 1, 2, 3, 4, 5, 6. 6 places. So I start with a 6, and then if you look at the pattern, it's just 6 plus 5 plus 4 plus 3 plus 2 plus 1. So as long as you get the first number correct, you just add all the way to 1 to get a simple answer 21. Okay, get the first number correct, the rest just add up all the way back to 1 and you get your answer. So you see, shooting method is so convenient. It helps us in so many ways. Okay, so whenever you see these sort of patterns, right, triangles or rectangles that sort of lines up in a row, you can use the shooting method to try out. All right, with that, let's look at another case. Shooting method is useful. Now, how about this picture over here? Do you think you can use the shooting method? Well, actually not quite, because shooting method works when there's only one layer, right? Just now we have one layer over here, one layer of triangles. But here I have multiple layers of triangles. So in that case, maybe we can observe some other characteristics. You can see that the left side has 1, 2, 3, 3 layers. And the right side also has 1, 2, 3, 3 layers. So it's a symmetrical figure, symmetrical in the sense that on the left and on the right, the situation is almost the same. So let's just focus on one side first. Okay, on this side on the left, how many triangles can you see? I can see a small one, but is that it? Oh, this is not the triangle. No, because there are actually bigger triangles, right? I have one blue triangle. The next one, maybe this is not that clear. A yellow triangle. Okay, that is slightly bigger. Okay, it's very ugly. A yellow triangle, right? And finally, a green triangle that is the biggest one, exactly the red triangle that I just highlighted. So on the left, I actually see 3 triangles, right? So the small, medium, large. Okay. Now, what about the right? The right is exactly the same as the left. So if that's the case, I don't really need to calculate it again. If it's exactly the same case, symmetrical on the left and on the right, then this number of triangles is the same, 3. Okay? But do I only have 6 triangles? Think about it. I can still form some triangles by combining the left and the right, right? So for example, these 2 small triangles, together they form another triangle, right? Okay, and then I can form a slightly larger triangle by including 2 of the parts below them. Okay, and finally, this whole triangle that I've highlighted in red, I mean, it's a triangle, right? So how many more triangles can I form by combining the left and the right? Okay, I can form 3 more, right? Small, medium, large again. Okay, so in this case, I need to take a look at 3 parts. If the triangle has 2 symmetrical parts, okay, first look at one part, okay, one side, for example, the left side. Then if you count it correctly, then the other side will have the same number of triangles. Just like here, left is 3, right is also 3. And then finally, make sure to count the triangles that can be formed across both sides. Okay, and finally, remember to add them up. Okay, left side, right side, both together. Add them up. So in this case, how many triangles can we form? 3 plus 3 plus 3 equals 9 triangles. 3 on the left, 3 on the right, and 3 combined. Okay, left and right. Okay, I see that a lot of you are trying to answer along with me. So try a question by yourself as I talk through. Okay, you can do that if you're very confident. Okay, if you're a bit unsure, it's okay. Just follow my steps. Okay, so looking at this question, oh, again, you can see that the left and right are symmetrical. So symmetrical as in what's happening on the left is also happening on the right. Okay, the exact same situation. So with that, we just need to count for one side because it will be the same for the other side. Okay, so one side you've counted, the next side it will be the same. And don't forget to count the triangles across both sides before you add up to find the total. So let's take a look at the left side. Do you think there are only 3 triangles in this case? 1, 2, 3, right? Hey, pay attention. Look at this line segment. I have a lot of points, okay, to form line segments from. And each line segment, okay, or each point, it will shoot towards the same vertex. Okay, doesn't this mean we can use the shooting method? So look at this here. Number the line segments again using the shooting method. 1, 2, 3. I have 3 parts, which means on the left, if I want to use the shooting method to shoot to the vertex on the left, how many triangles can be formed? That will be 3 plus 2 plus 1 equal to 6 triangles, right? So on the left, I already have 6 triangles. What about on the right? Hey, I am shooting to a different vertex on the right. But I can still use the shooting method here. Straight away, I know right side, I have 6. Okay, I have 6 triangles. Okay, but don't forget, okay, I still have the triangles I can form by combining. Okay, combining both sides. How many triangles can we form? Now, as the question has highlighted for you, I can form a big triangle in red. I can also form a slightly smaller, flatter triangle in light green. Okay, using these 3 sides. Even flatter, can I? Yes, okay, there's one more triangle that is slightly shorter. One triangle in blue like this. So we have the red, the light green, and the blue. That means combining both sides, I will have 3 triangles. So left side 6, right side 6. Combining together, I have 3 more. Just add them up, and I can find the total number of triangles. That is 15 triangles. Okay, so whenever you see symmetrical situations, consider one side, the other side will be the same. Okay, then remember, what if you combine them both? Can you form extra triangles using both of the sides, parts from both sides? Then add up to find the total. Okay, and be careful. Maybe you can use shooting method in some sites. Okay, so that is for counting triangles. Enough counting triangles and rectangles. Okay, moving on, we are counting squares. Now, when it comes to counting squares, there is a different method over here. Now, can I just say, look at this picture. How many squares are there? Okay, if you have a bit of experience, you should know how to answer this. But hey, let me tell you, if I just say there are 1, 2, 3, 4, 5, 6, 7, 8, a lot of y'all are giving me answers. Be careful in your calculation. Okay, y'all are almost there. Can I just say there are 9 squares? Maybe not. Okay, 9 squares is partially correct. It is 9 1 by 1 squares. The smallest square you can find, there are 9 of them, of course. But then, there are some bigger squares in this picture, right? What if I consider 4 squares combining together to form a 2 by 2 squares? 2 by 2 because there's 2 horizontally and 2 vertically. So 2 by 2. Can you find any 2 by 2 squares over here? Hey, I can find 1. Yeah, I see a lot correct answers coming in. Okay, keep it up. 2, 3, 4. 4 squares that are 2 by 2. Now, what if I go even bigger? Can I find a 3 by 3 square? I mean, it's right there, right? There's a big 3 by 3 square. Okay, so oopsies, 3 by 3 square over here. That is one big 3 by 3 square. So in total, how many squares are there? There are 9 1 by 1 squares, 4 2 by 2 squares. Okay, when you want to see 2 by 2 squares, just look for the cross in the middle and then circle the cross out. Circle the cross out. 4 2 by 2 squares and 1 3 by 3 squares. So in total, there are 14 squares. Okay, well done, everyone who tried to answer. Y'all got it correct. Okay, it's 14. Now, be careful. Squares doesn't mean the smallest 1 by 1 square only. You need to list in order of the size of squares: 1 by 1, 2 by 2, 3 by 3. Okay, now with that, let's take a look at the number of squares in the following picture. Again, let's first look at the 1 by 1 squares. How many 1 by 1 squares are there? We list them in order. So there are 5 in the top row, 6 in the middle row, 6 in the bottom row. So there are 17 squares. Now, how about the 2 by 2 squares? For 2 by 2 squares, remember, we are looking for a cross, right? And make sure the cross has been surrounded by a bigger square outside. So for example, this cross is one of it. This cross is one of it. Now, is this cross one of it? No, because if you look at what 4 squares are surrounding this cross, it is these parts, right? Let me use a different color. It is this part over here. And is this a complete 2 by 2 square? This is not. So be careful. Even when you are looking for crosses, be careful. Make sure it really does correspond to a 2 by 2 square. So this one is a correct 2 by 2 square. 1 more, 2 more, 3 more, 4 more, 5 more. So in total, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. Okay, 2 by 2 squares. Now, am I done? Hey, someone already said, yeah, it's 25. No, keep on going first. Can you see any 3 by 3 squares? Yes, you can, right? Where are the 3 by 3 squares? It is just one over here, right? Don't just be complacent. Stop halfway. Okay, you need to keep on going bigger, 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 bigger until you cannot find anymore. So this is the only 3 by 3 square I can find, right? If you try to fit other elsewhere, there's none. So there's only 1 3 by 3 squares. Okay, so with that, we can find the total, which is 17 plus 8 plus 1 equal to 26. Okay, we have 26 squares in total. List them in order, 1 by 1, 2 by 2, 3 by 3. And that's the key to counting the number of squares. Okay, and you can use the circle the cross method for 2 by 2 squares. It's easier, okay, and more convenient. Okay, final trick I want to share with you, the highest level Kung Fu today. Okay, this time I'm finding the number of triangles. But can I use the shooting method? Well, maybe yes, maybe not, right? You see, there are some line segments here, some line segments here. Are there any clear layers that you can find? Unfortunately, there aren't any. So with that, we are going to first label the triangle parts. Okay, I don't care whether this part is a triangle or not. Label it first. Okay, and then after I label, list the possible triangles according to the number of parts. Some triangles, one part is already a triangle. Some of them require multiple parts, so we want to list them in order. And then finally, remember when we list, again, list in order, okay? One part, two parts, three parts. So over here, how many triangles are there that can be formed using one part? Is part one itself a triangle? No, it has four sides. Okay, be very careful. Not every part is a triangle. Okay, so part one is not a triangle. Part two is a triangle. Part three is a triangle. Part four is a triangle. Okay, so we need to label the one part triangles first. But that's not all. Can I find any triangles that can be formed using two parts? Now, again, we follow the order from small to big. Okay, can one, first let's look at the smallest number, part one. Can part one be combined with any other part to form a triangle? Yes, 1 and 2. So we write 1 plus 2. Now this doesn't mean 3. This just means the two parts combined together. 1 plus 2 is a triangle. Any other else? Right, 1 plus 2, also 1 plus, 1 plus 2, also 1 plus 3, right? They can be combined to form another triangle. Now can 1 plus 4? No, 1 plus 4 is totally separate, so we cannot use them to form a triangle, right? So then let's shift our attention to 2. Can I say 2 plus 1? Cannot, because 2 plus 1 and 1 plus 2, they are the same triangle, same parts. So only count them once. So we only look for numbers bigger than 2. So in this case, actually 2 plus 4 is another triangle. Okay? And then after we consider 2, we can consider 3 as well. 3 plus 4 is another triangle. Okay? So 4, don't need to consider, it's already the last part. Okay? So for two parts, we have 1, 2, 3, 4, 4 triangles, right? And for the one part, 1, 2, 3, 3 triangles. Okay, don't stop here. Okay, even though two parts, I found a lot already, we need to still continue for 3 parts. Now, any triangles that I can find using 3 parts, you can try one by one, right? 1, 2, 3, 1, 2, 4, 1, 3, 4, 1, 2, 3, 4. 2, 3, 4, right? These 4 are not triangles, so we can skip this case. But don't stop here, okay? Don't give up. Okay, just because one part doesn't mean if I increase by another part, if I use 4 parts, it doesn't mean there are no triangles using 4 parts. In fact, 1, 2, 3, 4, the entire triangle is already one triangle. So we have one more triangle formed using 4 parts. 1 plus 2 plus 3 plus 4. So that's one more triangle. Okay, don't stop halfway. We need to keep on increasing. All right, this is slightly different from squares. For squares, if you find out there's no 3 by 3, you can stop considering. From here, you need to keep on going. And in total, just add all of them up. 3 plus 4 plus 1 equals to 8 triangles. Okay, with that, we have found our answer. Okay, so now let's quickly look at the question from All-in-One Guide, basic question 8. How many triangles are there in the figure below? Again, a lot of parts. It's okay. Label first, then list them in order of the number of parts. So let's label 1, 2, 3, 4, 5, 6. Now, when I do labeling, I also like to label from left to right, top to bottom in order so that we won't miss out any numbers. Okay, so one part triangles again. One part triangles. How many one part triangles are there? So 1 is a triangle, 2 is not a triangle. Okay, it's a kite shape. Okay, 4 sides. 3, 4, 5, 6 are all triangles. So 1, 3, 4, 5, 6. You can check one by one. Okay, it is a triangle. Don't stop here, because we still have 2 parts. Now for 2-part triangles, again, we need to look from small to big, right? Let's consider the labeling from small to big. Can triangle 1 combine with anyone to form a triangle? Right, 1 and 4, right? 1 plus 4, they form a triangle. So 1 plus 4. Now, there's no more. Let's look at 2. 2 and which part can form a triangle? 2 and 4. What else? Other than 2 and 4, what else? There's also 2 and 5, right? 2 and 4, just now I formed one triangle. 2 and 5 forms a triangle. Okay. What else? What else? 2 cannot, so let's look at 3 instead. 3 and who can form a triangle? 3 and 5 can form a triangle, so 3 and 5. Then, let's look at 4. 4 and 6 can form a triangle. And then finally, 5 and 6 can form a triangle. Okay, you can check them later on. So you can see what I'm trying to do here. Inspect, right? Choose one part and then inspect this part with the neighboring parts. Can it form a triangle or not? Okay, and then don't stop here. Okay, even though we found a lot already, how many 3-part triangles are there? How many triangles can I form using 3 parts? Now, there's only 2. Okay, one of them is 1, 4, 6. Okay, can you tell me what is the other triangle that can be formed using 3 parts? What 3 parts should I use? 1 plus 4 plus 6 and 1 plus 4 plus 6 and, okay, now there's also the same thing happening on the right, right? This diagram is symmetrical. So 3 plus 5 plus 6 also is a, triangle forming using 3 parts. Okay, now can we stop here? Let's not. Okay, 4 parts. Okay, 4 parts. Which triangle can I form using 4 parts? Now, if you notice, this is almost the same as before. It's just this triangle over here. 2, 4, 5, 6. Right, 2 plus 4 plus 5 plus 6. And there's no more. There's only 1. Now, you can also check, okay, any triangles can I form using 5 parts? Now, you just need to see, if I delete any part here, is there a triangle? There's none. Okay, so too many parts cannot form a triangle. And if I use all 6 parts, obviously it's not a triangle. So we have finished our searching from 1 part all the way to 6 parts. So let's just add them up. Okay, how many triangles are there? 5 for 1 part, 6 for 2 parts, okay, 2 for 3 parts, and 4 for 1 part. So finally, 1 for 4 part. 5 plus 6 plus 2 plus 1, right? 2 plus 4 plus 5 plus 6 is indeed a 4-part triangle. Now we are adding the number of triangles, right? We are not forming a triangle. Add up the total number of triangles. I see y'all have given me the answer, 14 triangles. Very good. Okay, so this is the highest technology I'm showing you today. Just label the parts and then list out in order of the number of parts from 1 part, 2 parts, all the way to as many parts as there are. All right. So with that, we have come to the end of this lesson. We learned how to count cubes using counting columns and counting rows method. Okay, we also learned the shooting method to count the number of triangles with a common base, or they shoot to a common, vertex on top. And we learned what should we do when we see just nice some symmetrical sides in 9 triangles. Okay, and then I also shared with you some Kung Fu to count the number of squares and triangles. Okay, in these 2 cases, make sure list them in order, starting from smallest number of parts to largest number of parts. Okay, and with that, okay, hopefully you are ready for our 10 questions picked from our all-in-one guide today. Okay, so I will share the details in the group chat as well later on. Make sure to submit the answers by Thursday, 9 p.m. and then submit a completion proof, just this screenshot, okay, on your group chat so that you can earn a star. Okay, we are already on our 4th week. Okay, 2 more weeks, you can earn 5 stars and get a mystery gift from us. Okay, and last but not least, okay, for those who may have missed this, okay, during the start of the live stream, very important point here. Okay, we are starting our registration for P2 SASMO and SMKC's mock test. We have an online mock test in the end of February. SMKC will be on the 20th February, which is a Thursday. Okay, and SASMO will be on the 25th, which is a Tuesday. Both timings are the same, 6 p.m. to 7:30 p.m. Okay, let your child, okay, try out, simulate a test environment and see how he or she can perform in the test. Okay, if you are interested, scan this QR code, okay, on the left to register for the mock test. Okay, I will leave the screen on for 1 more minute. Okay, and then, and I will also share this in our group chats later. Okay, so please don't miss out. Okay, scan to register for our mock test. And with that, that's the end of our class today. Okay, and I'll see you next week for our final weekly drill for P2 SASMO. Okay, goodbye everybody. Hey, mock test, make sure to register, yeah? Okay, I'm looking forward to seeing you guys.